Good evening, student. Today my topic is application of Gauss law to find the electric field intensity due to a spherical cell. Here, this is the spherical cell where the number of positive charges are uniformly distributed on that surface of the spherical cell. And that spherical cell whose radius is capital R. Let a point P, this is the point P, which is at a distance R from the spherical cell. Now we have to calculate electric field intensity at that point P. Whether the point P, which lies outside the spherical cell or on the spherical cell, on the surface of spherical cell, or inside the spherical cell, so that we assume a Gaussian surface. That Gaussian surface behaves as a spherical Gaussian surface. So this is the spherical Gaussian surface. Okay. Here we write that. Already I have written that one. That is, consider a spherical cell of radius R, capital R, where number of charges, that is positive, are uniformly distributed on the surface of the spherical cell. Let a point P, which is at a distance R from the center of the spherical cell. Now we have to calculate electric field intensity at point P, where the point P lies outside the spherical cell or on the surface or inside the spherical cell. Okay, this is the theory. Okay, so we assume a spherical Gaussian surface passing through the point P. तेणु आम कौन करिबा गोटे गॉसियन सरफेस को ड्रॉ करिबा जो गॉसियन सरफेस की पॉइंट को पास करके जीव. ओके, सो दिस इज द गॉसियन सरफेस एंड दिस वन इज द स्फेरिकल सेल. क्लियर? सो नाउ I will discuss about first case. The point P lies outside the spherical cell. Okay. Here, case one. This one is the point P lies outside the spherical cell. That is R. That is the small r much greater than that of capital R. In that case, here in that diagram, this is the spherical cell whose radius is capital R, and the point P, which is certain distance from that, the center of the spherical cell, whose radius is R or whose distance is R. So this is the Gaussian surface. Now in that Gaussian surface we assume a small surface. In that surface, the orientation of area or area vector, which is perpendicular to that area. So this is the area vector which is perpendicular to which that small surface. It is represented as a ds vector, and we know that the point P, which is outside the spherical cell, here there are positive charges are uniformly distributed on that spherical cell. Due to positive charges, the electric field which are moving radially outwards. So in Gaussian surface, each point consists of electric field intensity they are moving radially outward and they remains constant. Okay, so in that case the electric field intensity is also moving radially outward. So both electric field intensity as well as direction of area, that is area vector, in same direction, that is electric field intensity, so that the angle between electric field intensity and area vector is given by theta equal to what? 0 degree. Clear? Here we write that according to Gauss law, the surface integral of E vector dot ds vector equal to what? The total charge for epsilon 0. That means the total flux linked to a surface, which is equal to 1 by epsilon naught times total charge enclosed that surface. So here the point P lies outside the spherical shell. In that case, in that diagram, the electric field intensity and the area vector both are in same direction and they are having angle 0 degree. So in magnitude form, the surface integral of electric field intensity is given by, that means S surface integral of electric field intensity and ds, and the magnitude is given by E ds cos 0 degree, which is equal to q by epsilon naught. That implies cos 0 is 1, so here you write E ds equal to q by epsilon naught. We know on that Gaussian surface electric field remains constant because the radius of that Gaussian surface remains same in all directions. Okay, so in that case electric field remains constant, so taken in outside E, that means integration of ds equal to q by epsilon naught. Here the integration of ds means here we are adding small surface, that addition is represented as integration, so it can be represented as E into the surface integral of ds means S, that is total surface, which is equal to q by epsilon naught. The surface of that sphere, that is represented as a surface area, or here we write E into the surface area of the spherical shell is given by 4 pi r square equal to q by epsilon naught. Here S means surface area of the sphere, so that can represent as 4 pi r square, which is equal to q by epsilon naught. That means E into 4 pi r square equal to q by epsilon naught, because surface area of the sphere is 4 pi r square. Okay, now that implies E equal to q by 4 pi r square epsilon naught. So this is the electric field intensity at point P, where the point P lies outside the spherical shell. Okay, now second case is case 2. Point P, which is lies on the surface of the spherical shell. Here the point P lies on the surface of the spherical shell. Okay, that is r equal to r, small r equal to capital R. Here in that case, the point P lies on the surface of the spherical cell. At that case, small r equal to capital R. That's why the electric field intensity can be represented as E equal to Q divided by 4 pi. That small r square can represent as capital R square, because the point P lies on the surface of the spherical cell. So here we write small r represent as a capital R. So Q by 4 pi r square epsilon naught. We write small r equal to capital R. So this is the required expression of electric field intensity at point P, the point which lies on the surface of the spherical cell. Case 3. The point P lies inside the spherical cell, that is small r, which is less than that of capital R. You know, the spherical cell, where the number of charges distributed on that surface, in that case there is no charge which is placed inside the spherical cell. That's why there is no electric field intensity inside the spherical cell. That is already I have discussed in electric field lines. Okay, तार अर्थ है आम जब गोटे स्फेरिकल सेल कनसीडर करवा सब चार्ज कौट रे ऑन द सरफेस रे एक्युमुलेटेड हे, किंतु केभे से माने इनसाइड द सरफेस रे रही पारिबे नाही, जद्वारा कि इलेक्ट्रिक फील्ड इंटेंसिटी इनसाइड द स्फेरिकल सेल केते रहइबो 0 रहइबो. ओके, सो इलेक्ट्रिक फील्ड इंटेंसिटी inside the spherical cell is 0, because there is charge, there is no charge placed inside it, because there is no charge placed inside it. That's why the electric field intensity inside the spherical cell is 0. From above 3 cases, we know that the electric field intensity outside the spherical cell is Q by 4 pi r square epsilon naught. In second case, on the surface, electric field intensity given by Q by 4 pi capital R square epsilon naught. And third case, electric field intensity is 0 inside the spherical cell. This one is outside on the surface. Okay, now we plot a graph between R along x-axis and electric field along y-axis. The graph is shown below. That means this is the graph. Here in x-axis R is there, and along y-axis electric field intensity is there. Now on the surface, the electric field intensity is given by what? That is Q by 4 pi r square epsilon naught. This is the on the surface. that is 0. This is the inside. This is the inside. Inside the electric field is 0, that is 0 electric field intensity. Where on the surface the electric field is, which is equal to q by 4 pi r square epsilon naught. What? q by 4 pi r square epsilon naught. That is, r can be represented capital R. So this is here. And outside this spherical cell, it can be represented q by 4 pi r square into epsilon naught. So here in that case, R represent as like that. Okay, so that means E, which is directly proportional to 1 by r square, is 0. On that surface, R equal to R. Because E depends upon R, it does not depend upon capital R. So this is the graph. Here in that above graph, electric field intensity inside the spherical cell is 0 because there is no charge present inside the spherical cell. But on the surface of the spherical cell, that means R, which is equal to capital R, that's why electric field intensity on the surface is maximum. This is the maximum. Outside the spherical cell, that means electric field intensity, which is directly proportional to 1 by r square, so that the electric field intensity gradually decreases when you increase the distance. Okay, so this is the graph. This is all about electric field intensity due to a spherical cell. Thank you.